So the next piece is a formula that is not on your reference table. This is a very, very special formula. You only use it if you have a specific wording in the problem. So the words that you need to look for is collected by water, or over water, or something about H2O in the problem. So if a problem says collected over water by water, you're going to write this formula down. PATM equals P gas plus PH2O. Now I'm going to explain what all those variables mean in just a second. I first want to explain the process of what's happening in the lab. So that's done in this picture here. So in this picture you have a tubing that is connected to something over here, just not shown in the picture. And then if you look close enough, you have a jar here that has water in it that's also in some sort of container that has water. So originally this jar was filled completely with water. But now you can see it has little bubbles in it. The bubble should tell you that gas is being formed. And as the gas is going inside the container, it is pushing the water down. This is called water displacement. You're collecting gas using a water displacement level, so you're able to see how much gas is being collected. So one of the labs that I've done in the past that we just don't have time for it sometimes is you'll find out how much gas is in a soda. So over here you would have Coca-Cola or something heating up, the gas would form and go into this container. And you would then actually calculate how much carbon dioxide was produced from that soda. To do that, you have to use this equation. Because the gas that's collected inside this jar is not just the gas that's coming through the tube. What happens to water over time if it sits out? It turns into water vapor. So inside this container you have that gas you're collecting, but you also have water vapor that's evaporated over time. So all this is saying is the total pressure equals the pressure of the gas plus the water, pressure of the water. So PATM is the atmospheric pressure. And it will be the pressure given. So the PATM does not have to be in atmospheres. That's not what the ATM stands for. That just means it's the atmospheric pressure. So on WRAL, you can go there right now, and you'll have an atmospheric pressure of what it is in Rocky Mount, North Carolina. And to do the lab, we would look at that number. P gas is always your unknown. You will always be looking for that variable in these problems. That's one of the things that makes these extremely easy, because you're always solving for the same thing. PH2O comes from a table that will be provided. You don't have to memorize the table. So for your homework later, or classwork later, you're going to look at the one that's in your notes. On the test, this table will already be on there. Okay. So the table here, you have several columns. You might want to make the lines that I've made on the table, because these columns, that's 1, this is 2, and this is 3. So this chart is based on temperature. So if I said the temperature is 30 degrees Celsius, I want to know the pressure of the water. You would find 30 degrees Celsius, go over, directly over, and you should see that your answer is 31.8. So you go directly to the next column of that temperature. So the oxygen was collected by water displacement. So as soon as you read anything that says collected over by whatever water, you need to write down PATM equals P gas plus PH2O. As soon as you read it, you're going to write that down and work that out. That's it. Okay? So the barometric pressure during the experiment was 731 millimeters of mercury. So where do you think that number is going to go into this formula is the question. Well, that's our given pressure. So which one of these is our given pressure? the PATM, equals P gas is always our unknown. So then we have pH2O. Where does that come from? It comes from the table. Now the table is based off of temperature. So you need to look at what your temperature is. In this case, your temperature is 20 degrees Celsius. So you're going to go to 20 degrees Celsius, which is here. Go across, and you should see that it says 17.5. And then you simply subtract 17.5 from both sides and get P gas equals the end. And the question just asked for the partial pressure of oxygen. So that's your answer. So the next example is almost like the example number one, but there's a little bit of a twist to it simply by what the question is asking. That's what's going to be key for this test, is reading the actual problems and figuring out what the question is asking for. So first, it says a quantity of gas is collected over water. So as soon as you read that, you're going to write PATM equals P gas plus pH2O and solve for P gas. No matter what the rest of the question says, if it has that statement in there, this is what you do. So PATM is always our given pressure. P gas is always our unknown. pH2O comes from the table. So this time our temperature is 100 degrees Celsius. So you're going to go to 100 degrees Celsius and go over, which is 760. And then you solve. So subtract 760 from both sides. And you get P gas equals 224.5 mmHg. Now, again, every time you come to a final answer that you think may be the final answer, go back to the question and read it. So it says a quantity of gas is collected over water at 100 degrees Celsius. Manometer to indicate the pressure of blah, blah, blah. What volume would the dry gas occupy at STP? So did we answer the question? Is this a volume? No, we found the partial pressure of gas at that. So we have not answered the question. All we found is the pressure of the gas. So what does that mean for the next step? You've done one step. The next part is to now find that volume. So what you have done is you have found P1. You have found the pressure of the gas at its first pressure. The question then is asking for the volume if you change the pressure to STP. So step 2 for this problem is to use P1V1 T2 equals P2V2 T1. You will have one of these on your test, and it will be worth 10 points. So you're going to have to do this step first. Take whatever number that you have here and plug it in. Now, since you found the 224.5 as your P1, this P you are done with. Cross it out. As soon as you do this whole spiel here, you're done with the pressure in the problem. Cross it out. Most common mistake is to plug that somewhere into the next formula, which is wrong. That's the pressure of everything. We don't want that. What else do we have in the problem? Where do we get the V's and the T's? So a quantity of gas is collected over water at 100 degrees Celsius. So that is our T1. 353 liters is our V1. We already have P1. There's no more numbers, but there is. Those three little letters, remember we talked about this in class. STP means standard temperature and pressure. Temperature will always be 273. Pressure. Standard pressure for this problem must be in millimeters of mercury because that's what P1 is in. So standard pressure in millimeters of mercury is 760. Where did the 760 come from? Where does everything most of the time come from? The reference table. Front page of the reference table, your standard pressures are there, and that's the one for millimeters of mercury. So then we're solving for V2. So to solve for V2 on both sides, you divide by P2 and T1. They go away. So you're left with V2 equals P1 V1 T2 divided by P2 T1. And now you simply plug in. So P1, remember, came from here, not anywhere else. Came from the first part that you did. So 224.5 times V1, 353, times T2, which is 273, divided by P2, 760, times T1, which is 100 degrees Celsius, so we need to add what to that? 273, so 100 plus 273 is 373, and solve. And you should get $76.3 liters. Now we will do more of these problems in class and also practice for work, classwork and homework.